All right, final part of the roots and factors problems are what I call the backwards problems. So now they're going to give you the roots or the zeros, and they want you to give them the original problem. So we're going to do these all backwards now. We've done this before, but only for x squared problems. Now we're going to do it for x cubed, x to the fourth, depending on how many zeros they give you. So example number 1 will be the easiest one. They've given you 3 real zeros. And they're all pretty nice numbers, so we call those rational ones. So if it has 3 real rational zeros, we know it crosses the x-axis at -2, 3, and 5. So it has 3 zeros, means it's the degree of 3. So we should be making an x cubed problem. Well, if -2 is the zero, x plus 2 is the factor. So we're making factors out of the zeros. Now remember, to make factors we go x minus the 0. So we change the sign of the 0. So if it's positive 3, the factor would be x minus 3. If it's positive 5, it would be x minus 5. So as if those are your factors, what was the original problem? Well, we're going to FOIL these together. And it doesn't matter what order you do it. So I'm going to do the first two. X squared, that would be minus 3x plus 2x minus 1x minus 6. Then I have to multiply that by x minus 5, which means I need to double distribute. Which these are all skills that we've learned way back. So we're going to use them all now. So multiply everything by x. X to the third minus x squared minus 6x. Now multiply everything by -5. -5x squared, positive 5x, and positive 30. I like to line mine up this way so that it's easy to add together. So it's x cubed minus 6x squared minus x plus 30. Now it says that it wants you to write it as a polynomial function, so you need to say that f of x is equal to that, and that would be your final answer. So that would be the original problem. Now you could certainly check this one by typing it in your graphing calculator and seeing if that's where it crosses the x-axis. Alright, a little bit harder. What happens when they give you fractions? Well, you have to remember how to make those factors. So what are the factors if 1/2 is an answer? Well, you have to remember that that's 2x minus 1. Think about that. That's 1/2 is the answer. So you have to be able to make those backwards. Now, this is plus or minus 2/3, so you need both of them. 3x plus 2 and 3x minus 2. So again, 3 zeros, they're real rational ones, so you should have 3 factors. Now I need to FOIL these together, and you can do it in any order you want to. Well, I notice that these two are no middle, so I'm going to FOIL those together first. That's 9x squared minus 4. Then I still need to multiply that by 2x minus 1. So again, you can think double distribute, or you can think FOIL. It doesn't make any difference. So it's 18x cubed minus 9x squared minus 8x plus 4. And you want that in descending order, and to make sure you put f of x is equal. So there's your final answer. Again, you could check that one on your graphing calculator and see that you get those zeros. What happens though when we get imaginary? We don't typically have factors when we have imaginary answers or nice factors, but we're going to pretend that we can, even though we don't normally do it that way. Remember, for imaginary, they always come in pairs. You never can have one imaginary. So if they tell you that 2i is a 0, then we know that -2i is also. So in this problem there's really 4 zeros. So I'm going to create 4 factors. We'll start with the real ones. X plus 3, x minus 3. Now I need 2 more. Well, I'm just going to make these into factors. So it's going to be x minus 2i and x plus 2i. Again, when we are normally factoring, we don't normally break this one down into 2 separate ones, but since we're going backwards, we're going to do it that way. Now you have to multiply these all together. It's going to be easiest if we do these two and then these two because they make no middles. So this one would be x squared minus 9, and this one would be x squared minus 4i squared. Remember, I squared is negative 1, so this is really x squared plus 4, which is how we would have stopped in our normal problems. And then when we solved this is how we would have gotten these imaginary 2i and negative 2i answers. Now you got to keep going. You got to FOIL this together. That would be, oh, I'm sorry, x to the 4th minus 5x squared minus 36. And again, you need to make it a function, so set it equal to f of x. And that's your equation with those 4 zeros. Now example 4 is the most difficult because the zeros are a little complicated to make. So again, if they give you 3 minus I, you automatically know that 3 plus I is also a 0, so don't forget that. We need to make the factors. There's 3 of them. So the first one's going to be x minus 2. So you change the sign when you put it in here. Now I'm doing this one. I have to change the sign when you put it in. So it's x minus 3 plus I. Change both signs. Alright, now I'm going to do this one. Change the sign when you put them in. So it'd be x minus 3 minus I. Now I've got to multiply all of that stuff together. I'm going to do these two together first. We've done this before, so you have to remember how to do this. You want to think about connecting this together with this. And now you have a no middle. You have x minus 3 squared minus I squared. The front squiggly line stuff times each other would make the squiggly line stuff squared. And then positive I times negative I is negative I squared. Well, what's I squared? It's negative 1. So that becomes plus 1. So we have x minus 3 squared plus 1. FOIL. X squared, multiply it times 2 minus 6x plus 9 plus 1 is x squared minus 6x plus 10. Now that's what you get by just FOILing these together. You still need to multiply the problem by x minus 2. So now you have to double distribute. And we're going to bring that up here. So multiply everything by x. X to the 3rd minus 6x squared plus 10x. Multiply everything by negative 2. Negative 2x squared plus 12x minus 20. So f of x is equal to x cubed minus 8x squared plus 22x minus 20 for our final answer.